All right, this is lesson 14. We are going to do this in 2 days during class, and there's actually not much you're going to be able to do at home. So I'm going to describe what we're doing in class, and if you can get the materials to do this on your own, you can do that, and then we can meet back in class to discuss the results. So let's look at this top. It says, in this lesson, we're going to investigate taking random samples and how random samples from the same population will vary. So remember, population is all things in that set. Samples are just a part of that. So how do we more accurately represent the population? So how do we represent the population the best? Okay, so we do this by taking random samples from the same population. So what we're going to be doing is we're going to be looking at one population, and we're going to be taking samples from that population. To do this, we're going to be talking about some Skittles that we are going to use. We're going to use the fun size bags of Skittles to use those as our samples. So I have a pack here. Those are the fun size Skittles. We're going to just look at this sample. Now, obviously, these are not all of the Skittles that were produced. Those are produced in the factory. This is just a part of them. So this will be our sample. Now, it says that it is known that 5 colors or flavors in Skittles should be equally distributed, meaning there should be the same number of colors in each bag. We want to determine how likely it is to obtain the distribution we see here. So given that the equal distribution is true, let's assume that each of your bags of Skittles represents a random sample. So that's what I said. Each of these sample or bags is a random sample. So I'm going to have them open it up. We're going to decide on what are the colors of Skittles that they produce. So when you open up that bag, you see that there are orange, there are red, there are yellow, there are purple, and there are green. So there are 5 different colors. It says, what is the expected proportion for each color? Well, you would think that each color is a fifth of the bag. Now, a fifth is 0.20 or 20%. So each color should happen about 20% of the time. So there should be about 20% of each color in the bag. So we're going to study that and see if that's actually true. So number 3 says, do you think random samples from the same population will be similar? So all of these bags, do you think they'll be similar in their numbers? You would think, because they're coming from the same population, that they would be similar. So yes, because the samples are coming from the same population, that they would all be similar. Now, obviously, they're not all going to be the same. That's not what it's asking. Similar means that they're all going to be alike, just not the same. So here's our activity that we're going to be doing in class. We are going to open up that bag, and we're going to actually determine the individual data for this actual bag. We're going to figure out what the proportion is of each color, meaning we're going to divide it by the total. And then we're going to make graphs for the whole class, because we'd like to see, are they similar or not? Once we do that on day 1, we're going to then look at more larger samples, not just the small bags, but maybe 5 small bags or 10 small bags. We're going to be looking at that too and seeing how closely related they are. If you'd like to get a bag of those Skittles and try this, you may. If not, you'll have to get one from me in class tomorrow. Good luck.